Cool. So let's move on to our next question on the menu. What is sine x divided by cos x? Let's say that's just our function here. Our function, let's call it f. F for function is sine of x over cos of x. Now, the question is pretty open-ended. What is this? Well, it is just a function. So if you wanted to, maybe if you wanted to do like f of, let's say, 30 degrees, you could just sub them in directly and deal with it that way. So sine 30 degrees divided by cos 30 degrees. That's going to be something I calculate real fast. This is just an example. Sine 30 divide cos 30. That's going to be 0.57735, on and on and on. But it really is that simple. You can treat this as a function, but let's say you're a little bit lazy and you don't want to like type this all into your calculator to calculate it. Oh my goodness, typing that many buttons, unacceptable. We can add a little bit more, or we can do something to this to make it simpler. Sine divided by cos x. So let's think back to our SOHCAHTOA triangles. Oh, nothing but good times here. SOHCAHTOA. So let's say that's our angle. This is our hypotenuse. Let's call that hype. I'm hyped up for it. Here we have our opposite. Not scared of the ops here. And here we have the adjacent. The amazing adjacent. That's the adjective I describe with adjacent. We know that sine of the angle is equal to opposite divided by hypotenuse. We know that cos of the angle is the adjacent divided by hypotenuse. Okay, so there's something else here. We know a tangent is opposite over adjacent. Up over adjacent. Let's actually send these equivalences into our original equation here. So originally we had sine of x. Of course, x and theta, you can use either one. Cos of x is equal to, well, sine on top is opposite over hypotenuse. On the lower end, we have adjacent over hypotenuse. We can rewrite this as op over hypotenuse multiplied by the bottom, but inverted, so we have hypotenuse on top. And adjacent. Oh, I see some mathematic magic. The hypotenuse on the top and the bottom of the fraction, they neutralize each other to 1. So sine of x over cos of x is actually equal to 1. I mean, not just 1. 1 times opposite over adjacent. And what is that equal to? Hey, that looks familiar. Tan. Tan of x, I guess in this case. So, anytime you see sine over cos, you know that, hey, I could do this manually like this, but why would I when I know that this is really just tan. Tangent. Okay? Does that sound good? Does that sound beautiful? Look clear? Anytime sine over cosine, I kind of think of it like a trapezoid. So you know sine has like 4 letters. And cosine has 6 letters. You know, it makes makes it like a little trapezoid. It's kind of like an umbrella and you use the umbrella to maybe avoid a tan, but you don't want to avoid the tan always. The tan is good. We say tan Q. Tan Q. Yeah. Okay, so that would be the solution to this question. And it seems that they have a similar description on how they came to the same conclusion. So sine x divide cos x, that's the same as tan. Think of the trapezoid and an umbrella for tanning. That's my way of thinking about it. So the above solution is correct. Cool. Sounds